So in our factoring unit, we also want to discuss how to solve a polynomial by factoring. And then let's review what the domain would be for this particular problem. Remember, domain is about what x values you can put into this equation. And we have no problems, no x's in our denominator, no radicals. So we would say that our domain is all real numbers. Or we can say that by saying from negative infinity to infinity. So if I'm going to go ahead and solve this, I just want to do my AM on this one because this is a 1. What adds to minus 6 and multiplies to 8? Well, I'm thinking a negative 4 and a minus 2. So I'm going to write that as a x minus 4 and then x minus 2 equals 0. Now you might say, Ms. Sorensen, this doesn't seem new at all. And you're right, it's not. But if I said solve for x, that means you're going to have x equals 4 and x equals 2 as your solution to this equation. You're solving it, okay? Why does 4 work? Well, when I plug in 4, I get 0 times a number would be 0. And same thing for 2. You plug in 2 here, you get 2 minus 2 is 0. So that's how you solve. You basically factor it and then set those terms in parentheses equal to 0. All right, how about this? What's the domain of this problem? Well, again, we have no problems because there's no denominator, there's no radical, there's no issues with what we can plug in for x. So our domain is going to be all real numbers or negative infinity to infinity. To factor this, I look for a greatest common factor, and that's definitely a 4, but also an x cubed. So this would give me an x minus, and then I have a 2, because 4 times 2 will give me my 8. And then I'm going to need another x. And maybe you just caught my mistake here. This should be a 1. How come? Well, 4x cubed times 1 gives me the 4x cubed. All right. So there I am, I'm factored. And now what we need to do is set each term equal to 0. So our first one is we're going to set 4x cubed equal to 0. Well, divide by 4, you get x cubed equals 0. Technically, you have to cube root both sides here. Okay, don't overthink this. You might have already guessed this. This answer is x equals 0. So that's one answer. The other answer is setting this 1 minus 2x equal to 0. Subtract 1 from both sides. Get negative 2x equals negative 1. Divide by negative 2. And you get an x equals a positive 1/2 because the negatives cancel. So that's our solution, because if we were to plug in 0, let's go ahead and do it. So if I plugged in 0 and a 0 here as well, well, this gives me a 0 minus a 0 does in fact solve my answer for a 0. And same thing would be true if we plugged in that 1/2. Now this problem is important. Maybe you want to star it on your homework or in your notes. We're trying to set a polynomial divided by another polynomial equal to 0 and solve. Well, let's deal with that in a second. Let's actually answer the domain first. And to do this, we know we have to factor. So I'm going to have factoring the numerator. We've already done this problem. That's going to be an x minus 2, x minus 4. Divided by, here I'm going to pull out a x, and I'll have an x squared minus 4. And hopefully you can see that that denominator is a difference of squares. So although I can't factor my numerator anymore, I actually can factor my denominator. This right here becomes an x minus 2 times an x plus 2. And if you're not sure why, that's because of difference of squares. You can go back and watch that video. So what is our domain? Well, remember, our domain is about what we can and can't have for x's. In this case, we cannot have a 0 in the denominator. Here we can't have x equal to 0. Here I cannot have x equal to 2. Here I cannot have x equal to negative 2. So if I go ahead and draw this on a number line here, I have from negative infinity to infinity, and then I've got negative 2, 0, and 2. So I can have all of these things, but I can't have a minus 2, I can't have a 0, and I can't have a 2. So let's go ahead and answer our domain. So our domain for this problem is going to be from negative infinity to minus 2, union, minus 2 to 0, union, 0 to 2, union, 2 to infinity. There you go. Unfortunately, that's half of the question, right? The actual question says solve this. And this is very interesting, folks. This question says, when is this fraction going to be equal to 0? Well, when is a fraction ever equal to 0? Well, this thing right here always has to be a number, like 7 or 6 or 5 or something like that. And to have a fraction be equal to 0, we need to get a 0 in the numerator, right? Because 0 divided by a number is, in fact, 0. So we can't have a 0 in the denominator, but what we want is a 0 in the numerator to solve this. So we look in our numerator, and when is this equal to 0? Well, when x is equal to 2 and when x is equal to 4. However, one of these answers is not true because one of these answers is not in our domain. Okay, remember, looking back at our denominator, we could not have a positive 2. See right here, we cannot have a positive 2. So this answer is not in our domain, so it is not a solution. We did not have an issue with 4, and so x equals 4 is going to be the answer to this problem. All right, let's try another one. Find when h of x is equal to 0 and state the domain. So basically, we're looking for when the numerator is 0, but we have to make sure that that value is in the domain. So our first step is going to be to factor. And 2x squared minus 9x minus 5, I'm going to have to pull that off to the side. We're going to have to do that telephone method. Remember that? So I'm trying to multiply to negative 10 and add to minus 9. So that would be a negative 10 and a 1. So I'm going to split this up to a 2x squared. I'll put my minus 10x plus 1, and then minus 5. Underline, underline, pull out the 2x. We get a x minus 5. I immediately write x minus 5 here. Then I need a plus 1. So this factors to an x minus 5 times a 2x plus 1. All right, so that's my numerator. Sorry, I didn't mean to yell at you. X minus 5 times a 2x plus 1, all divided by, now I have to factor the denominator, and that helps me find the domain. And this is one of those easy problems with the AM, so we can do this one quickly. So what adds to negative 4 but multiplies to minus 5? Well, that would be a minus 5 and a plus 1. Negative 5 times 1 is this. Negative 5 plus 1 is this. So for our domain, we cannot have x equal to 5, because that would make this whole thing 0. And we cannot have x equal to negative 1. So we're going to have from negative infinity to minus 1, union from minus 1 to 5, union 5 to infinity. And if you don't believe me, you can go ahead and draw that table out that we usually draw. All right, next step, now that we have our domain, is to find the solution to this. And to find the solution to a fraction that's equal to 0, we would like our numerator to be 0. So we want x minus 5 to be equal to 0, and we want a 2x plus 1 to be equal to 0. Solving this one's really fast. We get x equals 5. Solving this one, I get x equals negative 1/2. Now we have to check that both of these answers are in our domain. Unfortunately, we have that we cannot have 5. So it's kind of like an imposter. We cannot have this as an answer. However, our negative 1/2 is totally fine, so that is a solution. And folks, you can always check your work by actually plugging in negative 1/2 to x. Just make sure you remember your parentheses, and it should give you 0. All right, that's it for this video. Thanks for watching.